All right, y'all. So 9.4, like I said, is logarithmic functions. And a lot of these can be done on the calculator. So I'm going to explain what they are and how we find them. And then I'll show you how easy these are on your calculator, okay? So the definition of a log. So log is short for logarithm. So you'll have a subscript and then another number. So the logarithm, where I got the x, that subscript is the base of the logarithm. All right, so that's the base. Y is the result. And B is the exponent. So these logarithms, they basically find exponents. So y'all had to let a few in real quick. So they basically find exponents, okay? Which y'all in the long run, that means that a logarithm is an exponent. All right, so these undo exponents. Okay. So what this tells me, it takes the base. The base is the number being multiplied, and you have a result. So we look for the exponent that this base was raised to get that result. So I'll write that out for us. So a logarithm finds the exponent that the base was raised to get that result. Okay, so let me just show you a couple examples of what this is really doing, okay? So y'all, this first example, I'll do a log base 5 of 25. So what this is wanting me to find is what exponent would I raise 5 to get 25? So how many times you multiplying that 5 times itself to get me a 25?
5.
Well, not 5 times, right? Because that'd be 5 times 5 times 5 times 5 times 5. So
it's one time. Times itself one time.
okay, so you got 5 times 5, right? That's going to give you 25. So the 5 is getting multiplied times itself twice. So this would be the exponent of a 2. And to check myself, so if I wanted to check myself, I would take that base of 5, raise it to the exponent we just found, which is 2. And that 5 squared has to equal 25. So y'all, that is definitely true. Okay. So let's play with another one. How about a log base 3 of 27. How many times do we got to multiply 3 times itself to get me a 27?
3.
It's 3 times, right? Because 3 times 3 times 3. So they give you 9, and then 9 times 3 is 27. So since we multiplied it times itself 3 times, that answer would be a 3. So do you see how we're just finding exponents that you're raising this base to get them results, okay? All right, y'all, how about a log base 2 of, how about 32? So I'm looking for the exponent that I would raise this to get me a 32. So we would do what? 2 times 2 would give me 4. Times 2 gives me 8. Times 2 gives me 16. And then times 2 gives me 32. So y'all, that 2 had to get multiplied 5 times. So that exponent would be a 5. So let me just sort of throw a curveball at y'all and see what y'all say here. How about the log base 5 of a 1? So what exponent would I raise the 5 to get a 1 out of that? Oh, I'm going to get y'all.
Is it gonna be a 0?
Is it 0?
Okay, it'll be a 0. Because 5 to the 0 power is 1. Y'all, any base can be right here. If that results a 1, then that exponent has to be a 0 on that, okay? How about a log base 7 of 7?
Is that gonna be 1?
That's going to be a 1. So 7 to the first power equals 7, okay? All right, y'all. So before we look at a graph or two, there's 2 special logs that are on the very front of our calculator. One of them is just a log without a number on it. So this is right to the left of the, I think the 4 on your calculator. But this is what we call the common log. And the common log that's on front of that calculator is really a log base 10. So if you write a log without that subscript number there, it's automatically a 10 on that one, okay? And then right above it, to the left of the 7, there's a LN button there. Okay, LN is what we call the natural log. And y'all, the natural log is a log base E. So anytime I see that LN, it's really a log base E, okay? And that's the E we looked at last week. So let me go through a little bit of graphing on these so that we can look at that. And then we're going to start evaluating some logs, okay? And I'll show you how to find these pretty quick on your calculator. So graphing logarithmic functions. So logarithmic functions are what we call the inverses of the exponential functions. So if you remember last week, when we was drawing the exponentials, they came up, went through 0, 1, and then they started curving up pretty steep. This is exponential. That we did last week. We're going to look at logarithmic because they're sort of the inverse of these exponentials. So, a few things I know about logarithmic functions. They all go through the point 1, 0. So instead of crossing the y-axis at 0, 1, these are going to cross the x-axis at 1. So if this is 1 on my x-axis, they're all going to cross it right there, okay? Another thing, the domain is from 0 to infinity. And you'll see why I can't have any negative x's on this logarithmic stuff, okay? So you'll see a little bit later why we can't have any negative x's. Now, the third thing is it makes a vertical asymptote at x equals 0. That means it cannot cross the x-axis, the y-axis. Okay, because it's like a vertical asymptote there. That's because, y'all, it don't matter what my base is. There's nothing that I can do to a logarithm to get an answer of 0 out of it, okay? Nothing we can do in the real world. So what you'll notice is these graphs, since it makes a vertical asymptote, it'll come up, it'll cross through 1, 0, and then it'll sort of head towards infinity, slowly increasing in the right direction. Okay, so notice on the exponential, it had a horizontal asymptote at the x-axis. The logarithmic here has a horizontal asymptote at the y-axis, okay? This one crosses at 0, 1 on the y. This one crosses at 1, 0 on the x. So, on the calculator, we're going to go graph a few of these real quick just to practice on the calculator. So, we'll graph f of x equals log of x. Okay, so the graph on the calculator, I'm going to share my screen with the calculator. All right, I'm going to go to y equals. Now, this one don't have a subscript, so I can use the log base 10 on the front of my calculator by the 7. So I'm going to hit my log, and then that was log x. So I'll hit my x, close my parentheses. So y'all, if you remember the shape we just went through, watch this graph when I hit graph. And see how it sort of comes up by the y-axis there, curves around, crosses over at 1, and then slowly goes uphill to the right. Okay. Now, the next one, they want me to graph y equals ln of x. So let me clear this one out. ln is right by the 4, so hit ln, and then x, and then close parentheses. Now, y'all, you're going to notice this is basically going to have the same shape as we just did. So notice it comes up, crosses at 1, 0 again, and then goes uphill a little bit quicker than the one I just did because
Mine isn't showing the bottom line.
this curve right here.
Yeah, it's not showing that. It's
Oh.
just showing from like 0.
So do this, do a zoom, and hit number 6 for zoom standard. Usually that'll fix your window.
Okay, now it is. It fixed it.
Okay, so your window's good. There we go. So that's the basic graphs of these. So usually I just plug them in my calculator and start rolling with them. So y'all, what I want to really do now is show you how to find these logs on your calculator. So for these examples, they want us to find the logarithm, which basically means find exponents, right? So these will start around number 4. So the first 2 or 3 was just looking at the graphs like we just did. So they want me to find a log base 5 of 125. Now remember, we can multiply that out, but we also got a calculator that can help us. So y'all watch what I'm going to do. I'm going to go share my calculator, and I can put this logarithm in exactly like it looks. So I'm going to share my calculator here. I'm going to quit this and go to my main screen. So to get the logarithms where you have to put in the numbers, you would hit math and then arrow down until we find what's called log base. So on mine, it's A on mine. Once I hit log base right there and highlight it, I'm going to hit enter and it brings it on the screen. So now I can put my base 5 there, arrow right, and put in my 125. So y'all, before I hit enter, how many times do you got to multiply a 5 times itself to get that 125?
3 times.
And there you go, 3 times. Okay, y'all, so remember, hit math, arrow down, find log base, put in your numbers, hit enter, and be done, okay? So that was 3. So continuing on, log base 6 of 36. Now, a lot of these, y'all don't have to have the calculator. How many times you going to multiply that 6 to get me a 36?
2.
2. How about a log base 10 of 10?
1.
For one time. So remember, a while ago, I had a log base 7 of 7 that equaled 1. Log base 10 of 10 equals 1. So y'all, there's a property that goes along with that that says the log, if that base of the log matches that result, then no matter what, that's going to equal 1, okay?
Oh, okay. So if it's the same number, it's gonna equal 1.
If they're the same, if they match. Now remember, this log 10 of 10, I could have did this to you. So remember, if I just got a log by itself, it is understood to have that 10 down there, okay? So this would still give you a 1. Okay, just remember, this is the only number that won't be shown is the 10, okay? Every other base has to have that number there. See, oh, this one's sort of tricky. How about log base 3 of 1 over 81? So I will say this, when you got fractions, you're going to get,
-4. Oh, sorry.
oh, what did you just say?
-4.
-4, perfect. So the fractions create the exponents to be negative, and 3 times 3 times 3 times 3, 4 times will give you that 81. So y'all watch this. This one sort of, let's punch that in, 3 to the -4th on our calculator and watch what it'll give you. sort of checking your answer. So here's 3 exponent -4. So I'm going to hit enter. It's going to give me a decimal, but I'm going to turn that back into a fraction. And it's by 1/81. So fractions create negative exponents, okay? Let's see. How about the ln of 1? Now you got an ln button right on the front of your calculator, right by the 4, I think it is. But y'all, what did we say a while ago? No
It's
matter
0.
what the base is, if that result is a 1, I think I heard it.
0.
That's going to be a 0 no matter what, okay? So you could almost have your little property that says the log of any base with a result of 1 is always going to be a 0, no matter what that a is, okay? All right, y'all, log of a 1/10. So notice up here, they wrote log base 10. On this one, they didn't write the 10, but it's still a log base 10. So this one we could do on the front of the calculator also. And that's a fraction. So remember, since it's a fraction, y'all got to get me a negative exponent on that.
That'll be -1.
-1. All right, so y'all, here's a new property we got. Log base 7 of 7 to the 5th power.
Whoa.
So think about this. What exponent would I raise 7 to turn it into a 7 to the 5th power?
I would say 1.
Well, 7 to the 1st just gives me a 7. So here's your base 7, right? You got a base 7.
Mhm.
What do you got to do to that 7
1.
to make it look like this 7 to the 5th?
Is it 1?
Well, remember, 7 to the 1st is just 7.
7 to the 5th is making the same, don't you?
It's 7 to the 5th. It's going to look the same like this right here, right? So if your result is 7 to the 5th, then that means this base you have to raise to the 5th power to make it look like that. So that would be a 5. So y'all look at this property based on that. A log base a of a to the x will always equal x. If you got a base raised to an exponent, the answer is always going to be that exponent. Because guess what? A to the x equals a to the x, right?
Mhm.
All right, let me see what y'all remember about radicals. Log base 5 of the cube root of a 5.
Whoa.
Well, let me fix y'all a second. Recall this one property. And it deals with radicals. So this is a cube root here. I'm just doing the nth root to show you the pattern. We can rewrite radical expressions as fractional exponents. Since there's not an exponent by the a, the top number would always be a 1. This little index or the root goes to the bottom of the fraction. So the nth root of a can be rewritten as a to the 1 over n.
So is it gonna be 5, 1/3?
So I'm going to rewrite this as log base 5 to 5 to the 1/3. So I rewrote the cube root of 5 as a 5 to the 1/3.
Okay.
So y'all, what's this answer? I got log base 5.
Is it 1/3?
It is 1/3. Because the base matches the base raised to an exponent, the answer will always be the exponent. But y'all watch this. We got a powerful calculator here. So I'm going to go to math and arrow down to my log base. Hit enter. So my base was a 5. And then I had a cube root of 5. Well, y'all guess what? If I hit math again, look at the number 4. Number 4 is a cube root. So I hit enter. And I'm going to put my 5 under that. So I'm doing the log base 5 of the cube root of 5. So I'm going to hit enter. Now remember, it's giving me a decimal, so I'm going to hit math and enter twice to turn that into a fraction. And there's that 1/3. So these follow a lot of exponent rules because they're really similar to those exponents, okay? All right, y'all, here we go. Log base 10 of 10 to the -5th. What y'all getting?
Oh, -5.
-5. Now, you can punch that on the calculator. You can use the log base if you want to put in the 10, or you could have just used a log on the front and did log of 10 to the -5th. Either way, you would have got that, okay?
But there's no point really because it's gonna always be the exponent, huh? I mean, to check your work, of course, but
Yeah, but I'm like you. If you got that property down right there, where it's always equal to an exponent, I'm just writing exponents and moving on, okay?
okay.
Now watch this one. The result is smaller than the base. When the result is smaller than the base, you should get a fractional exponent. So let's go punch that in. So I'm going to go to my log base on that calculator. So math, and I'll arrow down to A on mine. Hit enter. So the base was a 8. And the result was a 2. So y'all watch this. When I hit enter, I get 0.33, which I'm going to turn back into a
1/3.
1/3. So that means since my exponent's a 1/3, that means you got to take the cube root of 8 to get me a 2. Okay? So remember, fractional exponents, y'all, that's just these radicals in the skies right here, okay? Alrighty, y'all, so let me get my next page here. All right, how about this one? Log base 23 of a 1. Oh, that's taking y'all too long on that one.
0.
There's going to be a 0. All right, y'all. ln of e to the -5th. Remember, ln is a log base e. So I got a log base e of e to the -5th. What's that giving us?
-5.
-5. Because remember, that ln is a base e, so that base matches that result. So it's always going to be the exponent, okay? Y'all, these ain't bad, especially with those calculators. ln of the 5th root of an e. So I'll do it by hand, and then I will show you how to do a 5th root on that calculator. So y'all, I got my ln. Remember, that's an ln, not an in when y'all do math lab, okay? When you punch in the ln, it'll actually make it bold. Now, here's my e.
You want the fraction or the decimal?
Do what now?
You want the fraction of that? 1/5?
I want the fraction on this. That'll be a 1/5. Good job.
Yeah.
So, since this can be rewritten as ln e to the 1/5, what's the answer? So I got a log base e of e to the 1/5.
It's gonna be 1/5.
It's going to be 1/5.
Okay.
Okay. Now watch this, because remember, let me show you on the calculator, it has the cube root listed. So I'm going to clear off all this old stuff. But y'all, when I hit math, if you look down there on number 4, that was a cube root. Number 5 does every other root. Now I want y'all to see where that is before I actually do it. Okay. So I'm going to use that number 5 with the X in front of it. But you have to work them a little bit different. So let me show you. So I'm going to punch in my ln first. So ln's on the side by the 4. And then it was the 5th root of e. So since you're doing a root higher than 3, you got to hit the 5 first. So since I'm doing a 5th root, I'm going to hit the 5. Then I'm going to hit math and arrow down to the one that had the X in front of the radical. So that's number 5 on my options. Now watch what it does when I hit enter. It makes that a 5th root on that radical.
Okay.
And then underneath, I'll just hit second to divide to put my E in there. Arrow out, close my parentheses. So y'all remember, it'll probably give me a decimal first. 0.2, but when I turn that 0.2 back into a fraction, I get my 1/5. So remember, any root higher than a 3, you got to hit the number, then go get math and get the radical with the X, okay? All right, y'all. So then we learned how to convert between logarithmic and exponential. And this is going to help us next class when we solve equations. So here's the property on this. A log base x of y equals b. And then I'm going to draw a line with 2 arrows on it. This line with 2 arrows means if and only if. So the log base x of y equals b if and only if x to the b equals y. So the log of the base result equals the exponent if and only if the base raised to the exponent equals y. This is how we will convert between logarithmic over here, and this is exponential. And you'll see when I solve log equations, I try to rewrite them as exponential. When I solve the exponential, a lot of times I'll change them into logarithmic. So we got to be able to convert back and forth. So for the next few examples, we're going to convert to a logarithmic equation, and then we'll go the other way, okay? So if I'm going to convert to logarithmic, they're going to give me the exponential, okay? So 10 to the 4th equals 10,000. So to convert from this exponential to logarithmic, we're first going to write log. We're going to figure out our base. Well, notice the base of the log is the same thing as the base of the exponential. So this is my base raised to my exponent to get my result. So this will be a log base 10. The result is the 10,000. So the log base 10 of 10,000 gives me the exponent of a
4.
4. There you go. Okay, y'all, so just follow these patterns when you're converting everything. Let's try this one. 243 to the 1/5 equals 3. So you're going to write log. What's the base of the log? Well, the base of the log is the same thing as the base of the exponential.
It's gonna be 243.
So it's going to be 243.
And then
My result is the same thing as the result of the exponential. So that'll be 3. And then the exponent, I would raise this 243 to get a 3 is
1/5.
1/5.
So we just rewriting it.
That's all we're doing, rewriting.
Okay.
Okay. Rewriting them without the rewriting them from this exponential form into this logarithmic form.
Okay.
How about e to the 5th equals r? So I'm going to write my log down. So the base of this log,
It's E. E
the r, the result,
is R
and that's going to equal the exponent of a.
5.
There you go. Now this one you could rewrite another way, since that's a log base e. We could put this as a ln of r equals 5.
You
So-
said we could put that as a what, Mr. Eugene? LN R equals 5.
we could do the ln of r equals 5.
Oh, okay.
Because remember, ln does stand for the log base e.
Log. Yep. Okay. Okay.
Well, y'all try this one. P to the k equals 81. So when you get good with numbers here, they're going to change it up on you, throw these letters at you.
It's gonna be log P,
Uh-huh.
and then over 81. No. Is that right? Yeah, over 81, and then equals K. That
Yeah.
number on the end threw me off. Okay, equals K.
That's always so the result of the exponential sort of goes in here for the result of the logs. You just
Okay.
got to get used to this being your result here, okay?
Okay.
So that P to the K equals that 81. All right, y'all. Then they want us to go the other way. So we're going to convert to exponential. So convert to exponential equation. All right, y'all. So they're going to give me the log and we write it as exponential. So they're giving me log base 5 of 125 equals 3. So for exponential, I need my base. Well, the base is the same as the base of the log. So your base is going to be a 5. Your exponent is the 3. And 5 to the 3rd has to equal
125.
125. So basically the same thing. We're just going in reverse now. Okay.
Yeah, it's like a totally different. Yeah.
How about this? I'm going to throw a curveball a little bit. Log of 0.1 equals -1. So what would my base be?
0.1.
And that's my result.
Oh my god. What? Okay. I'm lost on this one.
So what did I say number was here if the number's not shown?
One.
And remember, I called it the common log.
E?
No, that's the natural log.
Okay.
Log of 10.
There you go. If there's not a number shown, y'all, it
Okay.
is a 10, okay? So the log is a log 10. The ln is the log E. So that's your base is the 10.
Okay.
Raise that to the power of -1. And that's going to equal that result of a 0.1. Okay, so just remember, base, result, exponent, okay?
Okay.
ln of 52 equals 3.9512. Now we're going to have to get used to rounding stuff 4 decimal places like they are on this one. Because if they're not perfect numbers like 5 to the third giving me 125, if it's a different result, then that's a product of that number times itself, then you're going to get never-ending decimals, okay? So I'm going to ask y'all this. ln of 52 equals 3.9512. I'm going to rewrite it as exponential, but oh no, I don't know the base.
Is it gonna be LN 10?
Well, not a 10. ln is the log base what?
Is the log base?
E.
E, there you go.
I'm so backwards. Like,
Well,
why
think
did I
about
say
this.
E on that one?
A log is a 10, ln is the E. My exponent is 3.9512. And that's got to equal that result of 52.
Okay.
Y'all get the hang of these.
Okay.
Now watch this one. They're like, okay, we're going to throw letters at them. Log base m of a t equals -y. Now be careful in math lab. Capital letters have to be capital. Small letters have to be small in math lab.
So is it gonna be M? You said -y, M -y equals T.
There you go. Base, exponent, result. Good job. Alrighty, so now these next few examples, they actually want us to use the calculator to find the common log. Now, round it 4 decimal places. Okay, y'all. So these start at what? 25. Log of 64. Now think about it. There's not a base here. What would it be?
10.
10. So think about this. We're looking for an exponent that we can raise 10 to get a 64. Well, y'all, 10 to the first power is 10. 10 squared is 100. Well, that 64 is in between 10 and 100. So that means that exponent has to be in between a 1 and a 2. So now, y'all, on this one, common logs, I'm just going to hit the log on front of my calculator and see what I get. Now, remember, we got to round this 4 decimal places. So I'm going to hit my log and what I have, 64,
Yeah.
and enter. So y'all, that's what, a 1 point. So
Mhm.
4 decimal places will be a 80,
806.
and one more.
Okay, 806.1. So I was okay, 806.1. Oh no, 806.2.
8062, there you go. Because after the one you had a 7, so we round that bad boy up, okay? All right. Log of 2. So y'all punch that in and see what we get. Now we'll say this number's smaller than the base of a 10. So when the number is smaller than your base, you should get
0.3010.
0.0310. So 3010. So you get a number less than 1, okay? All right, y'all, log of a negative 36.
1.556.
Or are you actually getting a number on that?
Oh shoot, hold on. No, I'm not because I didn't even do it right. I didn't put a negative, so no.
Yeah, make me a negative on that.
It's the error. It's a non-real answer.
Okay. So think about this. You got a 10 here, right?
Uh-huh.
And you don't know what this exponent is, but that's got to equal a negative 36. There's nothing in the world I can do to that 10 and make that thing turn into a negative number, right? So since we're not able to turn the 10 into a negative number, in math, we're going to put does not exist. So that's why your calculator says error, non-real result. Because in the real world, you can't turn a 10 into a negative number, okay? There's no exponent that I can do that with. So that's not happening in the real world. All right, so they got us used to the log button. Now they're going to get us used to the ln button. So this one says use a calculator to find the natural log. And we're around this 4 decimal places also. Now remember, natural log is the LNs, okay? So 28 says LN of 53. So y'all push that in and round me 4 decimal places.
3.790.
All right, one more.
2. No, 3.
3, there you go. So, all right, 39703. All righty. 29. Oh, what I have? I have an LN of 0.25. And y'all, all I'm doing on those, I'm just going on my calculator, hitting that LN button, and I'm putting in 0.25. And hitting enter. So you're getting what, a negative 1.386. So the 2 has a 9 after it. So that 2 is now going to be a
3.
There you go. All right, y'all. So 30 says LN of a negative 1.19. So what y'all getting?
I was trying to let somebody else answer, but it's no real answer.
It's not a real answer.
Yeah.
So just like I couldn't turn a 10 into a negative 36, I can't turn an E into a negative 1.19. It's that negative that's killing us. So this one does not exist. And if y'all remember when I was looking at that graph a while ago, and those logarithmic, I said came up, crossed at 1, 0, and went out. That's why there's no graph on the left side of this. Because I can't take logs of these negative numbers. So that's why this thing is just going to forever head downhill. And it can't even cross this y-axis. Because there's nothing I can do to no numbers to turn them into zeros even. So it'll never cross over the y-axis. So that's why when I was talking about the domain, I said it from 0 to infinity, okay?
So, Mr. Eugene, would you say all of them that's ln to the negative or whatever, like 27 and 30, would you say that's always going to be a does not exist, or sometimes the negative does end up having?
Oh, guess what? ln to negative 27.
Oh, okay. Negative.
Does not.
Oh, okay. No, yep, does not exist. Okay.
Exist. So basically, if you're doing an ln and your a is negative, no matter what that a is,
Mm-hmm.
it's going to be a does not exist. Same thing up here on the logs, right?
Mm-hmm.
The log of any negative number, well, guess what? That's going to be a does not exist. I don't care what them a's are, -5, -500, -1/3. It just ain't happening, okay?
So it's only if it's a negative within the parentheses?
Yeah. They should always give you this in parentheses if they're wanting it to be negative, okay? And if you notice, when you punch that on your calculator, it's automatically going to put you a starting parentheses. So did y'all notice that?
You used to say it one more time, Mr. Eugene. Did we notice what?
Like when I hit log, it's
Uh-huh.
automatically putting parentheses out there.
Oh, yeah.
So it don't matter what I put in, a -1, anything, that thing's going to give me my error message. And if you notice when I hit 2 to go to the error, it's blinking right on that negative, ain't it?
Yeah.
It's telling me, hey, you can't do that in the real world. And just like my LN, so let me go back to my LN here. Clear this. And the LN's the same way, y'all. No matter what you put in here, as small as a -1, you're still gonna get. You see what it did?
Okay.
You see it put an I at it. What's the I mean? Imaginary, right?
Imaginary.
Yeah, so let me switch my mode back to real. And then when I do that problem, I get the error, okay?
What you said it to make it do that? Because I'm like, how he get that? Mine keeps saying error.
Yeah, you get the error unless your mode here. Whoops, let me get off the error here. If your mode is set into A plus BI down here, when I go to ABI, it'll give you the answer as a
imaginary number.
Imaginary number. See how it did the I? But that's not real, so you would say, hey, that ain't real anyway, does not exist in the real world, okay?
Okay.
Now, y'all, at the very end of this, they got problems where they want us to use what they call a change of base. So let me turn this page over. So these will say, find the log using change of base. This was back in the, whoops, I ain't even showing my page, am I?
I thought my computer
I'm about to say it's still a calculator.
All right, there we go. Find a log using change of base. So let me give you an example. This one has a log base 6 of 18. Now, on this one, I'm not using change of base. If I was y'all on my calculator, I would just use the log base. So go to math, arrow down, hit
Oh,
log
okay.
base, and you can put this in just like it looks. But back before they gave you that feature on the calculators, we had to do this change of base stuff. So to change a base, what you would do the log of the result divided by the log of the base.
Talk about on them old school calculators.
Yeah. The ones that only had the log and LN.
Yeah.
Yeah, this is how we had to do it. Now,
Okay.
this will give me the same answer as if I did use my log base, though, okay?
Okay.
So using change of base, and I'll do it both ways to show y'all. So change of base, I would do log of 18, close parentheses, divided by my log of my 6. Now notice what I get on that, 1.6131 or so.
Yep.
Now watch if I use my change of base, my log base. So log base down here, I'm punching in as a 6, and then my result was the 18. I'm still going to get, and you know what's even cooler? I can use the LN instead of the log stuff. I could do LN of 18 divided by the LN of 6. So I could use change of base using LNs, and y'all watch when I hit enter, I'm still going to get 1.613. So that's what we had to do back in the day.
Okay.
We didn't have that log base where I could put in that little 6 and that 18. So we either had to do the log divided by the log or the LN divided by the LN.
Was that the yellow calculators?
I know she's talking about them Texas
The
instruments.
what ones?
Them yellow Texas.
The yellow ones?
Well, let me say, the ones we had didn't even graph back in the day, okay?
Yeah.
Oh, okay.
You was lucky if you had a square root on the front and you can do cube roots and stuff.
Oh, that's why people be saying, that's why older people be saying, them calculators do the same thing.
Exactly.
No.
So yeah, the last few problems, they're just going to have you doing the log base stuff, what they called it, change of base, okay? Alrighty, y'all. So that's logarithms. So when we come in Wednesday night, we're going to do 9.5, and that's going to deal with properties of logarithms. Okay, so that'll be on Wednesday. And y'all think about this. We'll knock this out Wednesday. Next week, we knock out 9.6 and 9.7. That's the last material I'll have for my last test. So the week after will be Thanksgiving break. So that's a good time to catch up on anything y'all are behind. It's that Thanksgiving break. When we come back, we got about a week and a half before finals start. So when we come back from the break, we'll review for test 4, and we got to start reviewing for the final. So we'll have a pretty good chance, since we haven't missed any school due to weather or anything. We'll have a lot of good study time for our final, okay?
Okay, you said the final, you said that one got 20 questions just like the rest of them.
25.
25, okay.
Uh-huh.
It's just consistent of each.
Multiple choice.
Oh.
So you don't have to worry about punching anything in right, or do I need parentheses or whatever.
That's awesome.
So as long as you get the right answer, you're good to go, okay? So y'all
Can you go back to number 13 for me?
13.
I missed like
that would have been right here, I think.
no 19, I'm sorry.
19, okay. Oh, with the E to the 5th.
Yes.
Now, y'all, what'll get y'all, you got to watch out for,
Ow.
like if you're rewriting this using LNs, This is an LN, not an IN. When you punch the LN correctly, it'll make it dark and bold, okay? And when you punch into logs correctly, it'll make them dark and bold. If you don't get it to be bold and dark, then you probably put an I instead of an L, okay? So remember, that's a small L, not a capital I.
Okay.
Okay, thank you.
Mm-hmm. And y'all, that's the world of 9.4 for you.
Okay, and I feel like this is a dumb question, but a good question at the same time.
Uh-huh.
Will it be? You know how you make the reviews for the test. Well, after we do our review for the test or whatever, you know how you make the you give us a test to practice. Do we get that for the exam or no? That's just a one study guide and that one time and that's it.
So each of the tests has that review quiz that y'all got to do, and the final also has a
Review.
review for you.
Okay, cool.
Mm-hmm. So we'll knock out the 20 questions on test 4 probably after the Thanksgiving, and then we'll knock out the 25 for the final. So you'll know what questions will be on the final. Okay, they're just going to change up those numbers. But some of them questions on the final are a little tricky because they got the one with the what was it? A ladder leaning on the wall and stuff like that. The ones y'all did the Pythagorean theorem to, remember?
Yeah, I remember those. Why you say they tricky though? Because of it's a word problem. Just wrong in there? Okay.
Yeah. So, like I said, some of them are longer, but it just goes a little bit into each section. You know, pulls a question here, sort of over the major 25 things, okay? Alrighty, so y'all, that's all I got for today. So we'll come in Wednesday and we'll knock out 9.5, and it might even have a little support for 9.5. So I'll knock both of them out, okay?
Okay.
All right, so I'm gonna quit my sharing here. Oh, I just got one right when we got out. All right, so I'm gonna quit this recording.